The dark sand dunes seen in the middle distance of this panorama are part of a band of dunes called Bagnall Dunes along the northwestern edge of Mount Sharp. The dune field is evident as a dark band in orbital images of the area inside Gale crater, where Curiosity has been active since landing in 2012. Dunes are larger than wind-blown ripples of sand or dust that Curiosity and other rovers have visited previously on Mars. One dune that Curiosity will investigate in the future is as tall as a two-story building and as broad as a football field. Ripples on the surface of these Martian dunes are larger than ripples on the surfaces of sand dunes on Earth. Several craters can be seen in this region on Mars that are filled with layered rock often exposed in rounded mounds. The bright layers are roughly the same thickness, giving a stair-step appearance. The process that formed these sedimentary rocks is not yet well understood. They could have formed from sand or volcanic ash that was blown into the crater, or in water if the crater hosted a lake. This panorama shows contrasting textures and colors of a hill at the northern edge of Marathon Valley and swirling reddish zones on the valley floor to the left. Marathon Valley was a high priority destination for the rover mission because observations from orbit detected clay minerals there. Dark rocks on the hill show a pattern dipping downward toward the interior of Endeavour crater to the right from this viewing angle. The strong dip may have resulted from the violence of the impact event that excavated the crater. Brighter rocks make up the valley floor, and the reddish zones there may be areas where water has altered composition. Inspections by Mars rover have found that compositions there are higher in silica and lower in iron than the typical composition of rocks on Endeavour's rim. For scale, the larger of the two stones close to each other in the foreground left of center is about 5 inches wide. This video shows the moment Perseverance rover landed on Mars's Jezero crater on February 18, 2021. The video was captured by several cameras that are part of the rover's entry, descent, and landing suite. The views include a camera looking down from the spacecraft's descent stage, a kind of rocket-powered jetpack that helps fly the rover to its landing site, a camera on the rover looking up at the descent stage, a camera on the top of the aeroshell, a capsule protecting the rover looking up at that parachute, and a camera on the bottom of the rover looking down at the Martian surface. Curiosity rover recorded this amazing video showing the passage of 12 hours on Mars. While the video doesn't reveal any clouds or dust activity, it did capture the remarkable passage of time as the sun rose and set on Mars. This iron meteorite was discovered by Mars rover on Meridiani Planum on Mars. The meteorite may have fallen on Mars in the late Noachian period and is extensively weathered. Curiosity Mars rover took this panorama while atop Mount Mercau, a rock formation that offered a view into Gale crater below. This view from Curiosity Mars rover shows a swath of bedrock which the rover approached for close-up inspection of selected targets. Curiosity rover found evidence for an ancient flowing stream on Mars at a few sites, including the rock outcrop pictured here. It may look like a broken sidewalk, but this geological feature is actually exposed bedrock made up of smaller fragments cemented together, or what geologists call a sedimentary conglomerate. Scientists theorize that the bedrock was disrupted in the past, giving it the tilted angle, most likely via impacts from meteorites. The key evidence for the ancient stream comes from the size and rounded shape of the gravel in and around the bedrock. The rock has pieces of gravel embedded in it called clasts up to a couple inches in size and located within a matrix of sand-sized material. Some of the clasts are round in shape, leading the science team to conclude they were transported by a vigorous flow of water. The grains are too large to have moved by wind. A close-up view of the rock reveals more details of the outcrop. Broken surfaces of the outcrop have rounded gravel clasts which is about 1.2 inches across. Erosion of the outcrop results in gravel clasts that protrude from the outcrop and ultimately fall onto the ground, creating the gravel pile at left. This is a very young crater on Meridiani Planum, which is around 100,000 years old. The damage to the plane's sediments caused by the impact of the crater-forming meteorite aids in converting sediment-embedded spherules into loose surface blueberries. This image is helpful for understanding the erosional processes that create the soils and loose blueberries. The background here shows a long-distance view of a field of plains ripple soil bed forms, as such background views are common at Meridiani Planum. This panorama shows the eastward horizon view near Endeavour crater. A portion of Endeavour crater's eastern rim, nearly 19 miles in the distance, is visible over the Meridiani Planum. This image shows a pit about 600 meters across that is bounded by a steep scarp on its northern side. Similar scarps in the southern mid-latitudes are known to expose water ice that extends to within a couple meters of the surface. The ice appears to be slowly sublimating into the atmosphere, causing the scarps to retreat towards the equator and enlarge the pits. This is the first high-rise image of this particular scarp acquired as part of an ongoing campaign to monitor the evolution of these formations that may provide an easily accessible source of water for future human explorers. The darker, bluer streaks extending away from the top of the scarp may have been caused by winds blowing sand out of the pit and or removing brighter dust from the surface. This clip was taken by NASA's Ingenuity Mars helicopter during its flight on Mars. Covering a distance of 2,310 feet and at a speed of 12 miles per hour, it was Ingenuity's longest and fastest flight to date. After reaching an altitude of 33 feet, the helicopter headed southwest and flew over a group of sand ripples. Then about halfway through the video, it flew over several rock fields at its maximum speed. In this view, we can see a network of prominent mineral veins below a cap rock ridge on lower Mount Sharp. Researchers have used Mars rover in the past to examine the structure and composition of the crisscrossing veins at this site. For geologists, the vein complex offers a three-dimensional exposure of mineralized fractures in a geological setting. Mineral veins such as these form where fluids move through fractured rocks, depositing minerals in the fractures and affecting chemistry of the surrounding rock. In this case, the veins have been more resistant to erosion than the surrounding host rock.